Alright, in this video we're going to introduce some of the different encapsulation types we might find in wide area networks and then get things set up to actually go configure these. We start talking about encapsulation like HDLC and PPP and frame relay, some of those really relevant ones you might actually run into while working with an ISP. So first things first, we're going to talk about different WAN technologies. We should probably define really what is the difference between a LAN and a WAN. And these terms aren't super well defined anymore, but the approach I'm going to take for these videos is we know the WAN is the wide area network. Basically, it's anything that we don't own. So if we're leasing equipment from an ISP, if we're relying on different providers' network infrastructure, that's going to be our WAN topology. And then the LAN side of things, of course, we think about our internal network, stuff we own, we manage. We're responsible for all of those pieces within there. Some of the common things you might see when you start talking to an ISP or really looking at the WAN topology is pretty well displayed in this chart here. So starting from left to right, we have the provider's toll network. That would be your ISP's routers, switches, all of their internal infrastructure. The CEO is called their central office. So if you're in the Sioux Falls area, this might be something like your Midco or your SDN headquarters. So really where are they based out of? Where does that service originate from? The local loop is how the ISP's network gets to more remote locations. So this could be a branch office for them. It could be the little green boxes sitting on the boulevard, the PED going into your house. But basically the cabling from them to a place close to the residence. The demarc point or the demarcation point is where the ISP says, my responsibility to get the network ends here. So that's something negotiable in your contracts with an ISP, but typically they'll say, we'll troubleshoot the line all the way up till where it enters your building, and after that, you're on your own. So it's where does their responsibility end? The CSU-DSU is basically like a modem for serial connections, and it's something that they bring into our networks. We can attach our serial-based routers to them and get some of this frame relay or HDLC or PPP encapsulation going back to them. CPE is your customer premises equipment. That's the routers, switches, all of that stuff that you actually own. So we kind of went through these already, so we'll kind of skip over this, but that information's there for you. This is a picture of a CSU-DSU appliance. Basically, you can see there on the left-hand side, there's an RJ45 port coming in. That might be coming in from your ISP. The CSU-DSU box is that gray box on the left. It's connected up to your router. This is just a little test router with a serial cable, and that's using the old standard serial cables. But from there, we convert that back into our LAN topology, going back out over Ethernet, doing those types of things. So when we actually start looking at bandwidth and how an ISP is going to serve us, there's a lot of different terminology we can get in there. I'll try to highlight some of the most important ones here. Everything is based off of a digital signal 0 or DS0, which has a signaling rate or a capacity of 64 kilobits a second, which is not very much. So the different types of communication we have, like a T1 or a T3, those are based off of multiple DSO circuits. And so that's how we end up getting the 1.544 megs, or in the case of a T3, 44 megs. If your business has lots of money, you're probably running an OC3 or an OC12, something like that. But basically it's just a measurement of bandwidth. Now something different about these than what you might have at home is a T1 and a T3 are dedicated lines. So the ISP is going to guarantee me I have 1.544 megs down, and it's typically synchronous, meaning that's 1.544 down and 1.544 up as well. So it's guaranteeing bandwidth that's not shared with any other customers. You own that much bandwidth. Now once you figured out the bandwidth requirements, we start talking about a little bit more topology things and how do we connect through an ISP from a corporate router to maybe a branch router, things like that. The first way to do it is with a dedicated or leased line, meaning there's basically a cable or a piece of fiber trenched from your corporate office, maybe through an ISP, and another cable trenched to that branch office. But at the end of the day, it's more or less a physical connection between you and those remote offices. Now that's very advantageous for you because you're not sharing that bandwidth, you're not sharing the line with anybody. It's pretty much a dedicated connection for you. The problem though, obviously that's going to be very expensive if they're laying infrastructure and cables for one client. Circuit switching is another way. It's a little bit cheaper way, and it's not really the best thing to use anymore. But basically what it uses is plain old telephone systems, so it's using phone wires to get data to your buildings. So it could be anything like dial-up. You could even think of DSL as circuit switching. Basically it's just using that phone media to get data to you. And the last one, which is pretty common, is called packet switching. And that's where you might have one line that's split between different customers that's used to save money. So you're splitting that infrastructure cost between multiple people. But also some of the downfalls with that is if one person's hogging a bunch of the bandwidth, then the other customers suffer from that as well. So even though they might give you a 10 gig link between a couple of buildings, the analogy I like to use is, if you're on a freeway and it doesn't really matter if you have 4 lanes of traffic that are full, you really can't go past them. If you had 10 lanes of traffic and they're all full still, you're not really any better off. So it's kind of how much openness do you have in that connection. And this is what they look like here. So synchronous serial or dedicated, just a one-to-one connection, circuit switched using the POTS, the plain old telephone system, and then packet switched where we basically have multiple connections coming in through that ISP. So one more encapsulation type we didn't talk about, and it's actually not shown here in this particular picture, is MPLS. MPLS is a combination of circuit switched and packet switched networks. So it's a really common thing. I think the two most common probably are frame relay and MPLS, but we'll look at what's supported and what we can do here in packet tracer, those types of things. So if you want to see what type of encapsulation your interface and your device supports, you can just do encapsulation ? This will be different from serial interfaces. If you did this on an Ethernet, this would be different. Basically, it's just each standard per interface is what we're looking at here. So there's many, many different ways we can configure the encapsulation between us and an ISP. And what I want you to think about when we talk about WAN support and these different things like frame relay and ISDN and HDLC is that they're really similar purpose to like what we see with cable or DSL internet. We're just using some sort of media, bringing internet service into your building, and depending on how that media speaks, we're going to need to encapsulate the data differently. So cable is encapsulated differently than DSL, that's encapsulated differently than frame relay, and so forth. But these are some of the common ones you might run into. We'll go through them real briefly. So starting out with frame relay is a packet switched, so kind of a shared type of encapsulation here. It's pretty cost effective because we can do not only point-to-point links, but we can do point-to-multipoint links. The bandwidth ranges for it are pretty good, 64K all the way up to a T3 at 45 megabits per second. And it does have dynamic bandwidth allocation and congestion control. One of the things you'll see with frame relay is basically we get a committed information rate from the ISP. So they're going to say we guarantee you 1 meg of throughput. But if nobody else on our same frame relay network is using that, we might actually be able to transmit faster than a megabit. So it's kind of a little bit dynamic there. ISDN is Integrated Services Digital Network, basically like the technologies we saw that use telephone lines to carry that data. Oftentimes you see this as a backup. So if we need just a cheap backup connection just to stay alive in the event of an outage, ISDN lines are really good. They're cheap, not very high throughput, but they will get the job done. HDLC is something that we've used every single time we've set up a serial connection in a Cisco device, whether or not we've known it. It's something proprietary to each vendor. So Cisco has their own proprietary implementation, Juniper does, Extreme Networks, Palo, whatever vendor is using HDLC has their own implementation. So that's one problem that we have with it is we can't mix different vendors. So PPP comes to the rescue for that. It works very similarly to HDLC, but it also allows us to do things like authentication, do some different things like compression and making a little bit better use out of our links there. PPPoE, same thing as point-to-point. like we just looked at, only it's using the Ethernet standard versus serial cables. So are you transferring media over Ethernet or is it going over serial? The only difference that we really have there. Cable internet, like we typically think of, and this is like what we would see coming into our house, is called hybrid fiber coaxial. The reason for it is from the central office, your ISP, going out to their branches or their PEDs out in the boulevards, is typically fiber cable. From that green box, the PED out in the boulevard up into your house, typically we use coax cable. And the reason for that is coax cable has been around for a very long time, and a lot of times we've had cable TV before we've had cable internet. So rather than needing to trench up everybody's yard and drill new holes in the house, we can just use cable. It's already there, it's already existing. Cable is shared typically, so we have 500 to 2,000 subscribers on each segment. If you're in the Midwest, like if you're in South Dakota, there's probably less than that. We're more geographically spread out and less densely populated than an area like New York, where it wouldn't be impractical for 2,000 people to be living in one apartment building. So it's shared bandwidth, even though we might be sold X megabits down, it's not always guaranteed. Some ISPs, like I'll pick on Midco here in South Dakota, they actually oversell bandwidth. So I only pay for 60 meg, but they actually over deliver that and I'll get like 70 something. Now, of course, that'll drop if more people are on the network in my neighborhood, but a lot of ISPs are trying to kind of race to that point of being the best in over delivering. DSL really is sort of the same thing here. It's got a little bit less bandwidth capabilities than cable internet, but same thing, we're just using the phone wires to bring that service into your house. Now DSL works by having a demodulator, which takes a phone wire, splits it into two, and is actually able to split out voice and data traffic, so you don't have the same problems you had with dial-up. You know, you can pick up the phone while somebody's on the internet, and that'll still work. MPLS, multi-protocol label switching. Again, this was basically a combination of circuit switched and packet switched networks. Your traffic is labeled, and this is very similar to frame relay, so it's almost like a VLAN tag, if you want to think about it that way. So you're given some number to uniquely identify your traffic. The ISP can look at that tag and figure out where does it need to connect to, what do they subscribe to, all sorts of those types of things. ATM, cellular, 3G, 4G, LTE, we all use it and love it on our cell phones. It's something that we kind of just expect to be there now. But it also does have places for business as well. An example of this I always think about, my brother did atmospheric research up in the mountains of Wyoming for a little bit, and it's really difficult to trench a cable up the side of a mountain. Like, we can all probably agree with that. So what they were limited to is either satellite internet or, you know, if it was good, they would have their 4G hotspots and could use internet that way. But you can actually plug LTE cards into your integrated service router, get service that way too. So a lot of cool stuff happening with 4G. Satellite or VSAT. This is traditional satellite internet. If you've ever used a satellite phone or satellite internet, you know probably a couple things. It's very slow, right? Because we're beaming internet up into space and then it comes back down to us. And by the nature of what that takes, from an infrastructure standpoint, it's super expensive. So we try not to use that kind of stuff if we don't have to. If you're on the International Space Station, for example, right, you don't have much options. But really the physics of how they're getting that is pretty neat. They have pretty good speeds even though they're really far away, just because of the line of sight and everything like that. Metro Ethernet, basically just Ethernet or fiber cable coming straight in your building, and it's just TCP/IP all the way through. It's also pretty popular to have, a little bit more expensive, but something that's catching on quite a bit here. So at the end of the day, cable, DSL, inside your network, it really doesn't matter. Once it crosses that modem, we just see TCP/IP. When we leave that modem, it's where we start to see these different types of encapsulation. So the way that cable is able to work is we have that small office or home office. It's typically the type of business we're going to be dealing with. Head end is where the cable comes in. The distribution network is all of those people that are connected to that same network. But how cable is able to communicate over this hybrid fiber coaxial is through technology called DOCSIS. Now, you've probably seen DOCSIS if you've been shopping for a modem, or maybe you lease one from your ISP. The way it works is coax cable communicates over RF frequencies. So coming into your house, it's RF frequencies over that coax cable. Your DOCSIS modem knows how to interpret those frequencies, translate them back into that digital signal, and then give us normal TCP/IP packets. It's a pretty confusing thing that's really going on if you think about what it is. But fortunately for us, all we need to know is really the job of the modem for that. So on cable, usually we have pretty big subnets and things like that. I think that's changed a little bit if you can actually find out the block you're on for a subnet mask facing outwards. You might see like a slant 20 or slant 21, kind of depending on where you're at. Average speeds for that, about 20 megabits. Remember, that's shared between everybody. In rural South Dakota, like I said before, we oftentimes see 70 or 60 meg is really common for us to have here. With DSL, it's just using normal phone wires coming into your house. So there's two types of DSL that I wanted to talk about. We have symmetrical DSL, where we have the same download and upload speeds. So maybe something you'd see similar to a T1. And asymmetrical DSL2, where we have different download speeds. So typically your download speed is going to be faster than your upload speed. Very common to what you see with cable. So with asynchronous DSL, right, we've talked about this before, you have both voice and data available, more download bandwidth and upload bandwidth, just going over phone lines, not a whole lot going on with that. And ADSL is typically an IDSN topology, so we have the PPPoE to help encapsulate those frames as they go across those phone wires. Last one I have here for you is Cisco Long Range Ethernet. This is something kind of cool. I haven't seen very much of it, but you get some pretty good speeds, 5 to 15 megabit of full duplex bandwidth. But what they're able to do is actually extend out Ethernet cabling to 5,000 feet. So normal Ethernet standards say you can go 100 meters, which is like 328 feet. So Cisco Long Range Ethernet, very cool technology like that. Like I said, probably not as common or maybe as practical as some of the other solutions, but something I thought you should be aware of as well. So moving on, we're going to look at HDLC, PPP, and frame relay in our upcoming examples here. And I wanted to talk about a few kind of differences and things we need to be aware of for that. When you see HDLC, PPP, or frame relay, we're thinking serial transmission. So we have a CSU, DSU in our building. We're connecting that via serial cable to our routers, and from there, we go back to TCP/IP. Serial is basically a bit-by-bit transmission technology, so it takes place one bit at a time over a single channel. On the left-hand side there, you see a smart serial cable. It's a newer, smaller one, and the old traditional serial cable, the big 40-pin. They basically both do the same job. It's just what type of card are you plugging into it. In Packet Tracer, we've been dealing a lot with the HWIC 2T cards. Those are going to be these smart serial cards. Now look closely at this picture here. The cable on the left, you'll see stamped with DTE. The cable on the right, you see stamped with DCE. And these two things have different meanings. DTE is usually your end device equipment, so the router that I own. DCE typically comes from something on the ISP. It's going to negotiate our bit rate, it's going to tell us what frequency that cable should be running at, and how much data or how much bandwidth it has to use. So up until now, we might have just been picking cables sort of at random, plugging them in, and it still works. The routers will actually negotiate who's going to be the DTE and the DCE based on that cable. But when you get into an ISP type scenario, typically they're going to control the DCE end, and we have to control the DTE end. So what it looks like again, if you take the computers on the right and the left, those are DTE. That's basically the receiving end of that signal. DCE, where that signal is probably originating from or being transported to us, and that's the ISP level. So we talked about this a little bit. Our bandwidth for those measured in hertz. Basically, that's the frequency of those cables, and that's what that DCE is providing that clocking rate for those. If you wanted to see what it looks like, you can just do a show controllers on a serial interface. It'll tell you which one is the DCE, which one's the DTE, tells you the clock rate on the DCE end. So basically what frequency are you allowing to go through that cable. Let's start out with HDLC. HDLC is an ISO standard, meaning it's a pretty open standard, but remember each vendor has their own proprietary implementation for it. Reason is the data link layer and physical layers are pretty controlled and they're not very often changed. With HDLC, the network layer, that third layer, is going to be where we start to have some discrepancies between different vendors. There's no authentication with HDLC, and basically what it's going to do is encapsulate our TCP/IP packet and place that into an HDLC frame. That gets sent across those serial lines, and everything is good that way. What it kind of looks like here is in that bottom HDLC frame, you see the data field. That's where your TCP/IP packets will go. Same thing with the Cisco HDLC, there's still that data frame in there. That's where your packets get encapsulated into. And then these frames, the two pink boxes, are what gets transmitted over serial. So we can actually stop here. We'll go through a quick video of configuring HDLC and PPP, and we'll pick it up from that.